Hi, I'm Thiago Fagionato, Healthcare Applications Engineer for Delcam North America, and I would like to show you OrthoModel on how to design orthotics based on the foot scan that we will get from the iCube system. Now that we have the foot scan on the screen, we're able to apply cast dressing operations and also design the orthotic based on the patient's foot shape. By turning on the crosshair cursor, I can analyze how the calcaneal angle is aligned. And I can rotate the foot by using degrees here. By rotating the foot on the screen, I'm able to see if the first metatarsal and the fifth metatarsal are touching the floor, and I can apply corrections to the patient's foot. So if I'm happy with the modifications, I can proceed to the next step, which is to change the orthotic shape. We can view the foot scan transparent, and we can analyze how the orthotic has been designed. For example, if I would like to make the forefoot width a little wider, I can select just forefoot width, and I can add increments of, let's say, 2 millimeters, and click, and I can change the lateral edge or the medial edge or both of them. Modifications like adjusting the arch height and etc. are also available on the list on the left-hand side in here. But one of the most important options that we have is the memory foam effect. It's how the orthotic is going to touch the patient's foot. And we have 5 options that we can use, which allows us to design an EVA orthotic which matches the patient's foot exactly. For the purpose of this demonstration, I'm going to use the full contact approach. So OrthoModel now is going to apply all the modifications. It's going to get the shape of the patient's foot. It's going to create an STL mesh based on the shape. And it's going to use the edge of the orthotic as a cookie cutter to trim out the shape for us automatically. Once OrthoModel finishes designing the orthotic, it takes us to the patient's detail page, where we can enter the patient's name, the orthotic thickness, and also do some more fine-tuning. But the user is also able to modify these values, as you can see on the menu here. I'm able to add modifications, such as controlling the forefoot width versus the rear foot independently, so we can apply varus and valgus. I'm going to select a rear foot posting as extrinsic. We can change the heel posting as well, such as adding a heel wedge or a heel lift for leg length compensation and for high heel shoes. We have a heel pitch and heel cup heights as well that we can control. After we design the orthotic, we can do cutouts, do a first mat cutout or a heel spur cutout. We can add metatarsal domes or plantar fascial grooves, and etc. Now that the orthotic has been designed, an extremely useful feature that we have in the software is the ability to show the foot scan overlaying on top of the orthotic. And we can see exactly how OrthoModel has designed the orthotic. But also the user is able to dissect the foot and the orthotic by selecting this option and check how the orthotic is touching the patient's foot, as you can see on the screen. Once we have finished designing the orthotic and we're happy with the design, we can then move on to OrthoMill to prepare for manufacturing. I'm able to select the material that I'm going to use to cut the orthotics and also the sizes as well. So I'm going to select one of the blocks that I have on my library. Then I'm going to select an orthotic so I can place on the block. And as you can see, OrthoModel tells me that some orthotics are not going to fit on a 1-inch block. I may need to select a thicker block. The last orthotic that I have designed fits the block because it's not as big as 1 inch. So I'm going to add the orthotic on the block, and I can position this orthotic anywhere on the screen or rotate this orthotic accordingly. And the software now is going to prepare the block and calculate the tool path for us. So OrthoMill is going to select a tool, it's going to design the tool path for the top, flip the block 180 degrees, create the tool path for the bottom, pick up a different tool, and do the cutout for us all automatically. Once OrthoMill finishes doing the process, we can also see how the tool path is going to work on the machine. Once we finish with the machining, we can then create the G-code, which is the XYZ positions that the machine is going to follow to cut the orthotic. And OrthoModel can also save the parts used workpiece. As you can see on this block, I'm just machining one orthotic, so I'm going to end up with a hole in this block. If I wanted to use this block tomorrow or down the road, I can select the same block with the hole in there, and OrthoModel is going to tell me exactly where it is to maximize the used material. So once we are done, OrthoModel also creates a setup sheet that tells us where we have saved the G-code, the sizes of the block, and what patients have been placed on the block, as you can see on the picture below. For more information on scanning, designing, or manufacturing orthotics, please go to www.delcam-healthcare.com.